Hey, how's it going, guys? Daniel here, aka HashLips, and what a journey it has been. But we're not done yet. So far, what we've done is we've actually been able to set up the front end in code. We've done things like set up the Redux, connect to the contract, and also retrieve the account, and a bunch of other things like migrations and so on. What we're now going to be looking at is actually implementing some styling, so it helps us going forward in this project to style things with styled components. So I'll briefly go over that, but so far it's been an interesting journey and I am so glad you guys are on board with me. Let's continue. So the next thing that we want to do is in the source directory, and like I mentioned before, you'll find these files on GitHub after this, but I'm going to paste another folder. Now the folder that I'm going to paste is called styles. Now, just to briefly run over these styles, we'll first look at the reset.css. The reset.css basically just resets all the CSS. As you know, when it comes to HTML, the markup language, there's sometimes CSS applied to certain attributes and tags that we want to clear out. So that's what this file does. So we'll import this in the index.js just in a second. The next file that we have is our theme. You can see that I make use of the root tag over there. And why we do this is to actually have access throughout the whole application using these attributes, these variables, but use them in CSS. Now that's very good, and there are better ways of doing this. I've simplified my methods of working just for this project so that it's easier to explain, and so we can keep the focus to the blockchain at hand. The next file we want to have a look at are the global styles.js. So this is a JavaScript file, and you can see that we make use of this styled from styled components. What are styled components? You can go and read this up. This is a dependency we've installed right in the beginning of this series. And what this does basically is you can take any kind of tag in HTML and create a styled component of it. So how you do that to a basic component is you'll say, well, const, give it a name, and equals to styled dot whatever. So if this was a paragraph tag, we can say style.p, or if it was a span, we can even do a span. Whatever you want to do, I just chose a div because a lot of people use divs, and I created these few styled components that we can use throughout the application. And I'll explain a bit more about them as we use them, but just keep in mind that these are here already set up for us. There's not a lot. There's maybe if I can count about 10 of them or 11, I don't know. But there's a few of these styled components such as screen, spacers, containers, and so on. But the interesting thing about these styled components, you can see there's a little bit of a weird syntax happening here. And what this is actually when you use a component in React, you pass it properties. Now we can actually grab these properties, and based on the values of them, we can change the value in the CSS. So for instance, if we used this styled div and we actually had the background color to whatever we've set it, but if we put the property test on there, and if it finds test, it will change it into pink, or it won't have any background color. And like I said, I'll explain more about styled components as we go along. Again, you don't have to use styled components. You can use CSS normally. The reason why I use styled components though is because it is a practice that a lot of people in React have adopted, and also it really makes your life easier. So needless to say, let's go and import this. Let's go to the index.js file and let's go and import the two CSS files that we actually have. So let's go into the styled and let's import reset.css. We want that one, and we also want to import the styles.theme.css, right? So we want to import both of these. And we want to go to the app.js file and import our global styles in here. How we're going to do that is we'll actually import, how do we do this again? We want to say we want to import everything as S. Okay. The reason why I have this weird syntax over there is because of one simple reason. It's that when we code, I want to be able to say S dot. And when I do that, I actually get the IDE suggesting me the styled components that I've created. So think of these components literally as a React component that you've created by yourself. So if you say container and we close it, this is a styled component that we've used. In the underlying architecture of this component, this container, if we look at the global styles and we go to the container, you can see that it's simply a div. Now, this style component has a lot of different things that we can do inside it. So we can actually attach props to it like flex 1, meaning that we are going to use flexbox and we're going to flex it to 1. We can do FD, standing for flex direction, and we can change it into a row. And you know what this does. If you don't, you need to sharpen up a little bit more on CSS before you take on this part. But that being said, I think you'll find style components very nice to use. There's just a convention which I use, which I import everything like this. All right. So basically, this is what we have, and let's just test this out. So what I'm going to do, and just to maybe explain this also a bit better, is I'm going to stick to divs. And let's have a div, and then inside the div, I'll have a p tag, and let's call it our game. And then after this p tag, what do we have? Let's have another thing. So maybe another paragraph, and then we can just say actually let's have a button in here. So let's have a button, and we'll call this button where do we put this? Is it the title? Okay, so we're going to have our game and connect and div and a p tag and a button. Now, this is fairly simple, right? So we can actually reload the page and we'll see this happening. There's our game, and then I don't see our button, which I'm just going to leave like this now. And it's probably because I got this wrong. So let me put the connect in there and see. There we go. So there's our connect button and there's our game. I mean, that's fairly simple stuff, right? So I'm going to try and do something now. I want to get hold of that, and I want to get hold of, how am I going to do that? Okay, I want to grab my code and I want to be on the React app at the same time, like this. And then I need to bring this in like so. Okay, the screen doesn't have a lot of real estate, but it's fine. I'm trying to just make a bit more space for you guys to see. Okay, cool. I hope you guys can see this, just so we can play around. So now what you can do is with any kind of HTML, CSS, and so on, obviously you can add some styles, which this is JSX styles. So what we can do is we can kind of give it a background color. Background. So with JSX, you type it like that. You don't put the dash in between. And let's give it a red, right? Now we can see that our div has a red background color. We can also give it the height and say, well, this needs to be 100 vertical height. This will fill the page. Let's not make it this red because it's burning our eyes. Let's make it pink. And there you can see there's our pink page. And then what we can also do is we can add some stuff. So we can say, well, let's make this display. Let's make it display flex. And we're also going to say the flex flex direction should be row, like so. And this is breaking because we need a comma. And there you can see now what happens is we get this flex where our game is, our title's there and our button is there. But because this all has now stretched down to the fullest, this button is also stretched down. So what we can do to just make it fairly cool there and not have it stretch like that is we can wrap the button and then make it not stretch. So we can put a div there, put the button in that div, and it should be fine. But then we need to go and have a little space there, and it becomes a mess. Okay, that's the one option of doing things. The second option is actually to create a CSS class, and then what you can do is say this is the class name is equal to some kind of class that you've added. Okay, but that's the other option. The option that I'm doing, and that why I'm using my styled components, are because you can create as many as you want to. You don't have to create them in the global space. You can create them in there, in the component itself. But if we had to rewrite this now, what I'll do is I'll say s.container. I'll create a container for this. And in fact, I won't create a container because we do have a outer component for that. I'll create a screen. And when I save the screen, you can see it goes black. All right. Next, what I want to do is actually add a container. So I can say, so let's add a container. And inside the container, I want a p tag, but in the style components, I do have a text. So text are p tags, but with a little bit of extra styling. So let's say we want a title. We're going to have a title, and we're going to say, well, this is our game, right? There we go. There's our game, and it immediately just looks a little bit better because this already has font onto it. So if we look at the global styles and we go to text title, you can see that it has colors, it has width, weight, and sizes on it. So this is how that works. And then let's give it a button. So we don't have a button yet, so we'll probably have to make do with our button. So let's say this is the connect. Let's do it all caps. Okay, so there's our connect button. Now this looks great and all, but let's center everything. Now how would we center everything? So you can also with styled components just give it a style. And I like to do this. I'll also make a video on it on how to style things and exactly know what you're doing when you're styling. So I'm going to do that pink so you can see what I'm doing there. A container does have a test already, but that goes pink. So let's give it a background style as well. So we're going to say background color. This one is going to be green. Green is also a nice color on the eyes. And we can see that immediately there's our green, there's our pink. Pink is going the whole screen around. But we just want to center the content maybe in the middle there. Now remember, containers are flex direct or displaying flex, so you have all the flexible properties. So you can go and write these in style, but because this is a styled component and we're working with props, you can actually go and say, well, justify content, because when you're using with flex, you have to look at the main axis. Main axis is always now for these components column, and then the side axis is row. So if the main axis is column, you can use justify to go up and down, but we want to align the items left and right or middle. So here what we can say is AI, which stands for align items. I know it's my own convention that I've done, so I'll just show you this quickly. In the container, you can see I've got all these abbreviations for flex direction, justify content, align items, test, image, and flex. All right, so that just gives us a nice way to center it. Okay, and so what we can do is we've centered it there. There's our game, connect. But what if we wanted this to be in the middle of the screen? Okay, so we would actually need to maybe give this a height of 100%, if that will work even. It probably won't. I just want to see if we need to give it a min height. Okay, because it doesn't know what 100% is, so we can also then just give it that. there. So we can give it that height, but I really don't want to do that. So let's backtrack a little bit because we already got a vertical, full-on vertical height here. So the best thing to do over here would be to align the items. Okay, so to align the items, because we want to do that, but then we have to display this as flex. So that is, oh, sorry, I am not thinking here. These containers are flex, so what we can do is we can just flex it to 1, okay? And then it goes and flexes to 1. So we already have the items aligned to the center. We can say justify content to center as well. And then once we've done that, there's our game and there's our connect, okay? Everything is green and ugly, so let's just take out these extra styles that we've placed in. Okay, cool. I'm going to do that, and there's our game. It needs a little bit of a space there between the button, and we do have a styled component for that as well, which we can say we need a spacer medium. Okay, once we've done that, medium is a little bit too big, so let's make it small. So once we've done that, I mean, there is our game, and it's flexible, and it's in the center. It's very cool and very fast. And if we find that this title is a bit too small, we can create a new styled component to make use of that. The reason why we want to use styled components, first of all, we reuse code, which is always great. And the second part is it looks better. First of all, I mean, you can read this much better than you could read the divs and the p tags and so on. And as components expand and get bigger, things get bigger, right? So that sounded wrong. Things, the complexity of the code gets bigger, and people jumping onto your project start struggling to find things. So that's why, for me, it's better to use this convention. But this I'll get into on another video. Like I said, we are here to focus on our game. So the next thing that we need to have a look at is actually how do we now take this code that we are busy with and connect it to our data on the blockchain, because we have already deployed the blockchain. It's there, it's waiting for us, but how do we retrieve that? Now that we've got this set up, we can connect to the account. We need to actually find a way how to connect to the smart contract and retrieve the data from it. We have one problem though, and that is that we have no way of retrieving the libs yet, which we actually want to go and get. Now, before we do that, you'll notice that in the Redux state, I've also added a data state with a reducer and an action, much like the blockchain. So in our reducer for this and data, we have an initial state where we have a empty array with all libs. We also have our loading and our error message, right? But we also have this extra parameter with the array. Next, we get our data reducer and we make sure that we actually update the state correctly according to what we give it. So at the end of the day, we would like to find an array of all of our libs. In the actions, what we do is we have our subsequent calls here that we do in the blockchain as well. And then we have a fetch data. Now the fetch data function is going to go and fetch the data from the blockchain. Now, how do we do that? You'll see here from line 28 to 31, we actually call a asynchronous call, calling a store, and the store is actually the Redux store. We import the store here at the top, and then we say get state. What state we're going to be looking at is the blockchain state, and in there's a lib token. Because remember, in our blockchain state, if we look at the reducer, we have a lib token. So we're actually referencing that. And then once there's something in there, we can call the methods, which will actually reference. So this lib token will be a reference to our smart contract. We'll call the methods on there, and we'll call the method get all libs. Now, get all libs does not exist yet, but we're going to create it in just a second. Then we append it with the dot call, and this call will asynchronously kick off and find all our libs and then put it in there. And lastly, we dispatch a success down here. All right, and that's basically what we're going to be doing right now. The last thing that we need to do is we just need to make sure that we actually have everything set up I accidentally deleted the Redux folder, so I just want to get the store back here. Okay, so our store file is back as it was, and we just need to now import our data reducer. So how do we do that? We basically need to import our data reducer in our store, much like we've done here with the blockchain reducer. So we can already go ahead and say, well, this will be imported from our data reducer, but we're just going to refer to it as data. We also need to import this from this is now going to be from data and then the data reducer, and that's about it. That's all we need to do kind of there for it to start working. We might hit some errors which we'll resolve, but first things first is we mentioned that we do not have this get all libs. Now the get all libs, we actually need to go and put that in our smart contract. So how do we do that? We go up to our contracts now, our libtoken.sol, and let's go down and see where would be a fitting place to put this. Here is a getter, and actually we do have a get libs. So we actually want to use this function. I forgot that we do already have this. So we can use this. This returns an array of libs, and we can actually then use this. So let's copy this function. Let's go back to our data reducer and change the get all libs to just get libs, because that's apparently what we called it, and then this should be fine. So optionally, you can see that in the fetch data, I pass in an account. Now, the reason for this is because we actually want to call fetch data by passing an account for if ever we want to get the account libs, because there's no way for us to know how, we know the amount of libs and we know the IDs that belong to the owners via the ERC 721 contract. But if you really think about it, we can't return an array of all the users' libs. So that's something actually we can implement on the blockchain to give that back to us. So let's do a new function in our smart contract. So let's go to libtoken.sol and let's type out a function. So we're going to say we need a new function. And our function is going to maybe be called, so that one is called get libs. Let's say get owner libs. Okay, and get owner libs will be a public function. It will be a view, and this time it will return. Okay, so what is this going to return? This will also indeed return a array. We need to make a memory. Let's do that and let's save it. I just want to see why this doesn't. There we go. It needs to do that. This time what we need to do is, instead of just getting all the libs, we actually need to pass in an address, and maybe let's just call this the owner, and we want to retrieve all the owner's libs. Now this function is a bit more complex, and I'll tell you now why, because we need to kind of filter and loop through all the libs and only retrieve the ones that the user has. Now you can do this in the front as well. I'm just going to show you this in the contract because we are dealing with smart contracts, and it's a good way to just show you this as well. What we're going to do is we're going to start off by creating a data type which is an array of libs, and we have to allocate this to maybe memory, and we're going to put this into the let's do the result, right? What this is going to start off with, if you initialize an array, you actually have to give it the exact length of the array when you initialize it. So when we initialize an array, you can do it like this, and in this field you need to say, well, this array is going to be the length of 10 or whatever you want to have it. But we need it to be the exact amount of libs that the owner owns. And how do we get that? Well, if we look at the ERC 721 standard, if we go and look at the contract, and stop, there we go. If we look at the contract, you'll see that down here we have a balance of. Now balance of returns to us a UN256 and it basically returns the amount of tokens that we have. So if we go back to our contract, and because our contract kind of inherits from ERC 721, then we can basically do that call. So we can say, well, we want the balance of, and then we pass in the owner, like so. Now this will initialize exactly an array length of the owner's lips, but it won't have the lips in there, right? We need to go and put them there. So what we can do is we can say uint 256 and then a counter, and we're going to initialize this counter as 0. Next, we're going to do a simple for loop. Now you've all seen for loops in JavaScript probably, but you can say uint 256. We're going to have a variable called I, and we're going to initialize that to 0. Next, what we want to do is we want to make sure that if I is less than the lips, so where do we get lips from? If you go up, remember we had our array here. So we look at that lips dot length, and then after that, what we do is we're going to increment it. So we're going to say I plus plus. So this is exactly how a for loop looks in JavaScript, and you can use it in Solidity as well. The next thing that we need to do is we need a little if conditional to check if the owner of I, so now owner of is also an ERC 721 function that exists. So we need to pass it I. Now the reason for that is I would be the ID, the index of the item. So if we say the owner of I, meaning it will return to us an address, okay? We can simply check if that owner of that particular NFT is equal to the owner that we pass it in here, it should do something. So we can then say the result of counter, okay, so we're going to now say, okay, the first result in this thing is going to be, well, we can equal it to the lips I. What this does is it actually assigns that particular lip into our new result array, and then after this we just need to simply increment our counter, okay, counter plus plus. After this loop is done, after the if statement, all we need to do is we need to return our result, and that's it. So this function get owner lips will return to us an array as well, similarly to get all lips. So let's go and implement those two. If we look back in our data, what we have are these two files, and the one is the reducer, the one is the action. So let's go to the reducer first, and let's go and update our initial state. Here we have already an initial state of all lips. But now what we can have is we can say, well, we need all the owners, all owners lips, all owner lips. Maybe all owner lips sounds a bit better. We can put it down here in the success state, and we can assign it to this. But this time we're going to be passing through the owner lips array. So if we go back to our actions, we can simply duplicate this call, because this call also needs to await for that. So what did we call it? All owner lips. And then here we actually will need to call the underlying one, and we'll paste it in as our success gets kicked off. So what we need to do is just in our lip token, just grab the correct method and put it there, and then we should be good to go and actually see what's happening, and if we actually get all the owner's lips back. So that is pretty cool. I think now we're at the stage to kind of test this out in the front, and there's one last thing that we need to do. We need to create some kind of functionality that we can mint more NFTs. So before we begin with that, just remember in the fetch state, so we forgot something. This account that we pass in here needs to be passed into our get owners libs as well, because if you can remember, the get owners libs that we just implemented now takes in the owner's address. So just don't forget to do that. I almost did. So once that's in there, we can now actually fetch the data. And this is very cool. So let's go and set up that function in the app.js so that we actually do fetch the data. Now what I want to do is I want to do something interesting. I'm going to add to our use effect, I'm going to add an extra dependency, and I'm going to call it blockchain. So every time the blockchain is updated, this will have to connect in some way. So we can't really put it there. It will create an infinite loop. So let's think about this for a second. We want the connect button to be there when we say connect. Okay, and if it's there, we actually want to connect. So let's actually move this button down into the action. So I think a button has a on click event, and you can access it like this. So we can pass it this, and because this is a button, we can also pass it a e for event. So the first thing that you need to do is you have to say e.prevent default, so we don't do some weird thing on the browser, and then we can put the dispatch connect there. This means that we actually move this functionality out of this use effect, and we leave it to our button to connect. That means that we actually give the button functionality, which it previously didn't have. Let's open the console. Let's look at what's happening, and there's a bunch of warning lines. These are from warning things that we're not using. So just forget them for a second. Let's say connect, and let's see what happens. Okay, there we go. So we refresh, and when we say connect, you can see that's when we've connected. And once we've connected, we actually will have an account. And I think that's the most important thing to check for. And as well, we need to check if we have actually a lib token. All right, so that's basically it. And once we've connected, once we get this object, there's no need to show this anymore. I mean, we are in the game already then. And by then, we need to kind of start displaying data. Now, I am going to do this in one page on the app.js, but obviously following proper React structures, you need to split this up in a better way. But needless to say, let's do this. So what we can do is we can actually have a few statements that runs in here. We can reuse the screen component, and maybe we don't have to reuse these. So what we can do is let's change this title to say connect to the game. Okay, we'll say connect to the game as an intro title. And what we want to do actually is, once this is showing, so in the blockchain we have a loading state, and we also have the account, and we also have let's just make sure. So if we go back to the reducer, we can see that our blockchain has these different states. Now to us, it's very important to make sure that we have an account and we have a lib token, because if this lib token is there and we have an account, we can basically connect to our game. So what we can do is we can actually have an if statement in here to say, well, if the blockchain dot account does not equal empty, and we need to have an and. So if we say the blockchain account's not empty, and as well as the, what did we call it, lib token is not equal to null. So as long as these conditions are fine, so if this is not empty, then we can render the game. So I actually want to change this to say if this is equal to empty, or let's do a or statement here. So let's say if the account is equal to empty, or if it's null, then we're going to display this. Else, so you put that the semicolons there, else we're going to render the game. And I think just for simplicity's sake, let's just put this in there and close this off. And then we can say maybe something like welcome to the game. Okay, so we can say that. Let's just change that to small letter G and let's run it. Let's see what's happening. Okay, so there it says welcome to the game. But if we refresh, let's see. So we say connect to the game. We want to connect, so we say connect, and boom, we've connected. So welcome to the game. Let's actually style this a little bit so that we can have a nice experience. So first, like I said, we want to align the items center. So let's just see if that works. We want to align it to the center. That's perfect. We actually want to give it some padding. So let's do this, style. I'm just going to do an inline style here for the padding. Okay, and then we're going to make this padding 24 pixels. So once we look at it, we can see that there's a 24 pixel padding over there. That is perfectly fine. I'm going to grab this small space over there, put that there, and then we're actually good to go. So now our game looks kind of like this, where we can reload and it says connect to the game. We say connect and it says welcome to the game, because we have all the data in here, which is pretty cool. We are connected to the blockchain, and this is now sure that we have an account and we have an instance of our lib token, meaning that now from this point onwards, we can actually now call the blockchain and query our things. So I just want to do, for simplicity's sake, take out this log, take out the console.log and just clear this and then refresh and then connect and see that what is missing and why are we getting these warnings. We can resolve these two very quickly because what we want to do is we want to take out this use effect because we're not using it anymore, and also this logo because it's not needed. I just want to do that to keep the project clean. So we might get this warning because MetaMask says something's going to be depreciated. But anyway, we have welcome to the game. And the next thing that we want to do is actually display all the HashLips tokens or the lib tokens in here. So that's what we're going to do now. So the thing is with this is we actually now need to, on the start of this, call the fetch. So we also need to then import this. So let's import. Okay. I think we call it fetch data, and this fetch data is coming from the data actions. This one. Let's just make sure that we have it right. Perfect. And then we are going to import this from the Redux. And we're also going to look into data, and then in the actions folder, we're going to import this function from. Now we need to kind of dispatch this somehow. So we're probably going to make use of the use effect again, even though we just took it out. But it's for a good reason, because in here, what we do want to do is we want to say dispatch fetch data and do that. Fetch data, if you can recall, it takes in account. Now, how do we get this account? Remember, we do have the account because it's sitting in our blockchain. There we go. But we won't have it if it's not there. So what we need to do is we need to actually say, well, this function is going to run every time that the blockchain.account gets updated. Okay, so that's going to run. And now what we can say is if, now we just need to do the opposite of this, because we need to say, okay, cool, if this one is not, if it's not equal to empty, then we want to fetch the data. And once we fetch the data, that's pretty cool. We can then look at it. It's moaning about a good and bad statement in the data actions. Let me just look at where that is. There they are. I'm going to take this out. These are just things that I've placed in for my existing game. These are just logs. So I'm just removing that so we don't get an error. Next, what we want to do is actually have oversight of this data. So I'm going to copy and paste this line over there because previously we pulled out the blockchain, but this time we want to pull out the data from the state as well. So we actually have that, and this is something that we're going to console.log. So let's have a look at that. Okay, cool. So let's see. We're going to reload the app and we're going to see there's our logs. So the first logs that we see is like all libs are like that. And then we get all libs are empty as well. Remember, because these are re-renders. But once we connect, we can see that our logs start changing and they are still empty, which is good. Nothing is breaking. And that just means that these functions are calling the blockchain, but nothing is being returned here because it's empty anyway, right? Our blockchain doesn't have any libs in it, so that is good. The next thing that we need to then do is simple. We actually need to create some kind of button for us to press so that we can generate HashLips. Now, what we can do is we can actually go in here and we can say, let's copy this button and let's put this button right below here, and we're going to call this create. Well, let's keep to the capitals. Create NFT. Okay, create NFT Lib. That sounds more cool. And then we need a different function to call here. Now, what function is this? Now, we can't just call the same thing like dispatch and go into the Redux to go and find this. We already have the blockchain here, right? We already have the blockchain here. So what we need to do is actually create a local function. So we'll start off with saying const, and here we can say mint NFT, like so. And minting NFT, we can literally, let's make it a pure function. So we can also say we want to pass in an account, and maybe we say we want to pass in a value, but let me just think about this for a second. But we're definitely going to pass in an account. So I'm going to do that. Okay, let's open the brackets. Next, because we do have the blockchain, and remember, in the blockchain, we have our lib token, which is the reference to our contract. So we can say lib contract token dot methods. And then in the methods, we need to call that function that we created right in the beginning, create random lib. And remember, this is payable. This we need to add a fee. And our fee is currently 1 Ether. So let's go and copy this and apply this here. So we're going to say that we actually want to call this, and what does it take? Remember, we said it needs to take a name. Okay, so apart from the account, we're also going to need a name. But let's keep to the underscore. Let's keep to the underscore convention. So we're going to give it a name, which we will probably put in there. And then after giving it a name, we need to say, okay, send. Right, so we need to send this transaction. Previously in our data actions, you'll notice that we do calls. Calls are things, are the blue buttons in Remix. If you remember our Remix tutorial, remember these blue things. These are the call actions, and these are the send actions. So just keep that in mind. So this is what you do if you need to call and get data. If you actually need to change things, you need to pay for the functions and so on, you need to do a send. So that's why it's a send at the end over there. And there's some other parameters that we need to put in as well. We need to put in a from, and the from is going to be from our account, the account that sent this. Now we need to do the value as well. Okay, so we can send the value, but now in layman's terms, how Ethereum works is, I think Ethereum has 18 decimals. So we need to do 1 with 18 zeros. So I think that's that. So I think we need to send that amount of way with this transaction. We'll see if this works. If it doesn't, we'll find another way. But basically, I want to end up using the Web3 utils, but I'll get to that just now. I just want to make it very clear what's happening here. The next thing that you can do is you can say once. Now, once will just basically pick up this if there was an error. So we can say if there's an error, then please do something. So we can give it a empty thing, and maybe we can just for the time being console.log the error. Okay, so let's maybe go in there and let's say I want to console.log this error. Okay, good. That's that. And then right at the end, basically what happens now is this then clause that you see here. This is very important. This then clause will kick off once the transaction is successfully mined on the blockchain. And this might take a while. So what we can do here is we can say this is the receipt. Okay. And then once we add the receipt here, we can work with it. We can log it out or whatever. But for now, I think we just want to log this out. The other thing that we want to do here is actually also dispatch the fetch data, because at this point we already have done this and we want to dispatch the data again. Okay, so let's see if this works. The last thing that we need to do is actually replace this function below here for creating an Nft Lib, and we are going to call this just like so. There's two things we need, and firstly we need the blockchain.account that we are calling this from, and let's call it Daniel, my NFT's name. Now you can have some kind of way of doing this differently and get that name for the people, like an input box, and then render it for them, and then you only call the function. It's moaning about an error, and I honestly don't know why. Why is this moaning about the error? Oh, because that console.log doesn't have an error. So maybe we can just console.log this receipt. Okay, that's it. So let's check it out. I have no idea if this will work. Let's go back to our browser, our React app, and there's the create NFT. Let's maybe refresh this for time being, and let's say connect, let's say create, and guess what, guys? Here we go. We basically opened up MetaMask, and there it is. There's the one ETH that we have. There is our transaction plus the transaction fee. And if we say confirm, it's now going to mine, and it's already mined, and it was successful. In the then clause, we do print out the receipt, and there we go. And we can see that this is what happened, right? There was our transaction. Everything went well, and we can see that this is our hash, and the events kicked off, and the two events that kicked off was new lib and also transfer. Now, if you can recall that in our smart contract, we actually emitted the new lib event and sending it this data after we've created a lib, meaning that it did go successfully. And also SafeMint kicks off the transfer event, but that is because ERC 721 does that. All right, so that's why you will see these two events. You don't see the actual data in them, but there is a way that you can subscribe to events and then listen to them on your smart contract on the blockchain, and then do front-end things like show the transactions happening, or you can index and traverse through the events and then maybe only show the users events. But generally it's enough to kind of rely on the receipt, show a loading bar while something is being created, and then go and stop the loading happening once this is ready. All right, so basically that's what we can do there. I would say one thing that I would adjust is the way that when we call it, that we kind of disable this button in some way. Let's see if this button does have a disable field on it, and it does. It does have a disable field, and it can take a Boolean. So we'll get into that right now. I just want to make sure, because After this call, the array should actually hold one lib, and it doesn't. And we can see that we do have an error message that says could not load data from contract. Now, why is that? Let's go and have a look and investigate and quickly debug. Okay, so upon running this program, what actually happened here, and you won't be able to see it now, but basically we couldn't run the function because it says it didn't exist on our smart contract. And that's exactly true, because even though we did add this new function to our contract to get all the libs, we never really redeployed our smart contract. So let's go ahead and do that. You'll need to cancel the running front end, or if you do this on another terminal, you won't need to do that. And then you can run truffle migrate reset. This will actually redeploy the smart contract on the virtual blockchain that we are running in this terminal, and you can see that this was successful. Next, you'll have to spin up the front end again, and then let's reload the application. And there we go. So we can now say connect to the game, and let's see what's the next error we are getting. So here it says invalid address arguments, and maybe it's because we don't have the address yet. I'm not sure, but let's go and say mint. And then yet again, we get a positive that we have minted the NFT, but we get a error over there. So it says invalid address argument address value is undefined. And let's go and have a look a little bit about why this is. So let's go and debug. Let's go and have a look at where do we actually go and connect to our smart contract. So let's go to the blockchain, and let's go down here, and we can see there's the contract.json. I just want to make sure that we actually are connecting to the right contract. So contract, there we go, lib token. I want to make sure that we are connecting to the right lib token there as well. And then just to make sure lastly that this is working, just refresh. We can connect fine, but as soon as this starts kicking off, we get an error. And we're getting an error on the data that we are calling. So we're getting this error over there. And it means that these don't work. And that is very strange. So let's quickly see. So we have fetch data, and let's just make sure that we're actually calling fetch data. Aha, that's our problem, because we are never passing in the account to fetch data whenever we call it. So we need to do that every time we do fetch the data. And that should be fine. So let's go back to our app and let's run it. Let's connect, and there we go. It still says could not load the data though, which worries me a little bit, but we're going to give it a shot. And it still says could not load data from contract message, but we do have an array, and there we go. We actually could load the data, so there is a little bit of a problem with our Redux, which is fine. I think what it's doing is it's never resetting on the success. Okay, so I don't want it to reset on the success, because then it's going to flash when we load it, but we can probably load the initial state over there. It would probably make sense. And then let's do it there as well. Okay, so initial state is there. Okay, so that means that our app's actually working. We've connected, we've created a smart contract, everything is working. apart from this error, which we quickly will resolve. So it says cannot read property methods of data. Okay, so where do we call this? This debugging process is actually beneficial. So I think it's good that we have a look at this quickly, right? We know that we can read that one. We just don't know if we can read this right off the bat. So that makes sense. Let's quickly go and have a look here. And let's do this. Let's go to the app.js. Okay, this makes perfectly sense. And the reason why this makes sense is because we are checking if the blockchain account changes. But we shouldn't really be checking for that. We should be checking if the blockchain lib token changes, and really be checking if the lib token is not null as well. So if this one is also if this one is not null as well, then only go and call that, because that will eliminate us getting that error. Okay, perfect, we're not getting it, so that's cool. We're not getting error messages. Everything is working perfectly fine. You can see on the first attempt when it connected, we didn't have any libs, and then once the smart contract connected, we actually got a lib, and there's our libs. So currently we have 2 NFTs on this smart contract in all the libs, and if we look at all the owner's libs, my address has 2 as well. So that is pretty freaking cool. I just want to do one more test where I actually switch ownership. So I want to switch to this account, and then when I come back here, I want to try and mint an NFT. So let's go and mint an NFT. And let's go and say confirm. And now, when we load the data, we can see that all the libs, there are 3 libs in the world, and all the owner's libs, which is this new owner that I just selected, only has 1, which is this. And it has the same name, Daniel, because that is a hard-coded string that we have when we create a lib there. So you can create some kind of input where the user inputs a different name for the character, but maybe what we can do is, for the time being, I think let's make it unknown, because then a user can maybe later on update their own NFT's name by interacting with a function. Like we can just build a function for that, right? So that is the next kind of thing that we now need to have a look at. How are we going to make this game exciting, and how are we going to add functionality and different things to it? We also need to take a step back and find a way how we're going to render these NFTs now on the page, because we are definitely getting the data back. We are definitely creating and minting NFTs, and we can do that all day long. But how do we display these NFTs here? A simple way of doing it, and if we look at the libs being returned here, we can see that each lib over there has these attributes. Okay, so just a simple thing that we can do just before we leave this tutorial, because I really want to leave you guys with something that you can look after for the next video that's going to be released. So what we can try is say, well, we need to render some kind of thing. So let's create another container over there, and in this container we're going to have a few different attributes. So let's grab a title. We're probably not going to have this as a text title, so we'll look maybe at a description. It's a bit of a smaller text, and we can do this. So let's go and see what our NFTs have, and I'm just going to quickly grab this, go back to our code. I'm going to paste this here, and we'll just do this so we can see. So we can say that we have obviously DNA, and we can put a space there, and then I want a few extra fields. Maybe we can also put the ID in there, just for now, just to kind of get a feel for how the whole NFT looks. Okay, so we can have a level, and then obviously we also have a name. And I forgot to copy one, but I know that we have a rarity. So we're going to have a name, a rarity, and ID, all these fields. Okay, so we can have this all in this container. So now what we want to do is we have this object. So let's just cut this for a second. So right underneath these this spacer, we actually want to loop through the array. So let's do that. So let's go and we say that we want to go through the data which we've imported, and we want to look at all libs. Okay, so what we want to do here is we want to map through them. So mapping through things are like looping through them. You can change values, but all we want to do is we want to return something. So we can actually return some JSX, which looks like this, and then we can use these items in here like so. So we can say item.id, and then we can do the same for all these ones and just fix it up with the fields. So we can say we have a level, okay, and then we also have the name, and we have the rarity. Perfect. So now we're mapping through all these items, and I don't know how it's going to look, but there it is. We get all these different NFTs, which is now level 1s, and we get the IDs. It's a bit difficult to see, so what we can do is maybe let's put a empty object in there, well, empty fragment, and then we're gonna say we need a spacer in there. So I'm gonna make a spacer small, just for time being, and we can have a look at it in there. There's some spaces there. Now maybe we can have these wrap, so we can even put them in a container and then wrap this container around the whole mapping. Get rid of that. Then we can say, so style flex direction, so we can put the flex direction to row. We will need to add an extra style because this I haven't coded into the styled component, so we need to maybe add a style flex wrap, I believe, and I just think it's called wrap. Okay, like so. And when we have this, we can actually see them going and wrapping, and yeah, so they're kind of responsive, but not really, right? What I do want to do is maybe say that we, because it's the row, we can say justify content, maybe space between. Why is that wrong? Oh, because we don't need 2 rows. Fair. Okay, connect. Yeah, and that should work better. Okay, there we go. I mean, there is our NFTs. So they might not look as much. They look you know, just like text. But if we create a new one, we can see that there's MetaMask. It asks us to mint one, and there we go. We mint another NFT, and then we can mint another one. And if I carry on like this, I'm going to be very poor with test ETH because it's costing 1 Ethereum each. But that's beside the point. I think when you get to this level of working with a contract, I think you're super excited, and I hope you guys are as well. The next step, like I said, I know this has been a long tutorial, but I just wanted to go in depth in these concepts. The next step that we can do is actually visualize these NFTs through images. Now, these NFTs are unique. They're not like any other NFTs where you get on OpenSea, you go and get an image like this attached to an NFT. And the reason for that is because when we mint these NFTs, we don't kind of mint the metadata on the NFT? Of course you can, but remember, our token contract generates the random ID for the data on chain. And we kind of have to use that on-chain DNA. So if you look at our app, we have to use this DNA field, right, to generate our kind of images on the browser, on the game. It's not sitting in metadata somewhere, because that is a video series for another day to kind of show you how to mint the metadata with the NFTs, but that's for a different use case, because that use case is more for NFTs that people buy, considering art and all those things. These are gamified NFTs, so we want to use the properties that it has. And it's much cooler that we can have these properties on chain, because these properties will forever live on chain. It's not something that sits in metadata. These properties that you see here actually lives on the blockchain as variables. So I hope you enjoyed it this far, this tutorial. I think what I'll do now is kind of start showing you how to visualize the data, how to put in the images, and how to have an extra bit of functionality so we can play around with these NFTs.